Sorry, I was having trouble getting my streaming software going. It took me a minute to get started. Your flight to the major airline hub reaches cruising altitude without incident. While you consider checking the in-flight menu for one of those drinks come with an umbrella, you're interrupted by the kid sitting next to you. Their handheld game console won't turn on. Ask you to take a look. You narrow the problem down to a strange infinite loop in the boot code. You should be able to fix it, but first you need to be able to run the code in isolation. The boot code is, oh good, this is when we start implementing with one instruction per line of text. Each instruction consists of an operation, ACK jump or NOP, and an argument, a signed number. ACK increases or decreases a single global value called the accumulator by the value given the argument. For example, ACK plus 7 will increase accumulated by 7. The accumulator starts at 0 after an ACK instruction. The instruction immediately below it is executed next. JMP jumps to a new instruction relative to itself. Next instruction is found using the argument as an offset, JMP instruction, so on. No op stands for no operation, does nothing. For example, consider the following program. These instructions are visited in this order. 0 to 1, and jump to the first infinite loop. The program will run forever. When the program tries to run any instruction a second time, you know it will never terminate. Immediately before the program would run an instruction a second time, run your copy of the boot code. Immediately before an instruction is what value is in the accumulator. Okay, that sounds good. We can do this, and we will try and do it nice and clean. Name tuple, and let's say raw is going to be this. Okay, and now I could use an enum, but I'm not going to because that seems like a little bit of extra work. But let's say class instruction named tuple, and let's use their terminology. Has an operation and an argument. And I'll just call it op, which is a string, and I'll call it arg, which is an int. Okay, and I'll say that a program is a list of instructions. Okay. Are you serious? I was trying to do from future import annotations because someone told me that would work with doing this sort of thing, but it seems like it won't. So I'll just go back to doing it my old way. So a program is a list of instructions. Actually, no, I'm going to make a class for this because it's going to want to, what do we want to call this? Strange infinite loop in the boot code. Game console. I'll call it a booter. Class booter, and init self, and instructions is going to be a list of instruction. And what will we do? We'll say self dot instructions equals instructions, and we have a global variable called the accumulator. And I think they said it starts at 0. Accumulator equals 0, and we will need a self.index, which keeps track of which instruction we're at. And self.executed equals set. And so now what we want to do is we want to say run self. Let's call it run until repeats self. And now let's do execute self and execute one self. Okay, and so let's say instruction equals self dot instructions self.index. This may end up being a terrible design, but it will work. Okay. And in fact, because it's a name tuple, I'm actually going to say op arg. If op equals jump, I'm trying to make this extensible because they'll probably have us use it again tomorrow. Let's do ACK first. If op equals ACK, then increase the accumulator by the arguments. Self.accumulator plus equal arg. Elif op equals JMP, actually, let me start with jump because I think this will, no, that's fine. And then self.index plus equals 1 is, I think, what they said. Otherwise, if op equals jump, self.index plus equals arg, I think is what they said. So jump, jumps to new, jump plus 2 would skip the next instruction, jump plus 1, no op, and then elif op equals, and was it called nop? Let's say nop, self.index plus equals 1, and nothing else happens. And then else, let's raise a value error. Unknown op. Okay, so that will run 1. And now if we want to run until repeats, we can say, actually we don't need this executed, this will be fine. So let's say executed is going to be set while self.index not in executed. Self.execute1, or actually let's say self executed.add self.index, so we'll say we executed it, and then so that's it. So now we need to add a static method to parse this. Static method, call it I never know whether to call it parse or from line. Line string goes to instruction. So I should have left the from feature import annotations just so I could use that one. Okay, and so now this will be real easy. Op arg equals line.strip.split, and let me just double check this. Int of +2, whoops, make sure the plus doesn't make anything bad. Okay, good, so that'll be easy. Return instruction op int arg. Okay, so we have that. So now let's say instructions equals instruction dot parse. I almost did a parse line for line in raw dot split on new lines. So let me just run this, and that seems pretty reasonable. And I'll say booter equals booter of instructions. I should really move my unit test to a separate file so they don't make such a mess. Booter dot run until repeats, and assert that booter dot accumulator equals and let's see, what do they want it to be? Value accumulator is 5. Okay, so that worked, and just to be like perfectly clear, let's print self.index comma op comma arg and just run it and make sure that it really agrees with K0 no op 1, then 1 ac1, then 2 jump 4, then 6 ac1, then 7. Whoops. The dangers of having a touchscreen, I guess. Okay, so that seems to be doing the right thing. Good. So let us get my browser is hanging, which is not good. Okay, so with open input day08.text as f, raw equals f.read, instructions equals again instruction.parse line for line in raw.split on new lines, booter equals booter with the instructions, booter dot run until repeats, and print booter dot accumulator. Okay, so let's try that one. And 1727. So I think that's going to be right, because if I'd really screwed it up, it would have like left the program space. After some careful analysis, you believe exactly one instruction is corrupted. Somewhere in the program, either a jump is supposed to be a NOP or a NOP is supposed to be a jump. This program is supposed to terminate by attempting to execute an instruction immediately after the last instruction in the file. By changing exactly one jump or NOP, you can repair the boot code and make it terminate correctly. For example, consider the same program from above. If you change the first instruction from NOP plus 0 to jump plus 0, it would create a single instruction infinite loop, never leaving that instruction. If you change almost any of the jump instructions, then the program will still eventually find another jump instruction loop forever. However, if you change the second to last instruction from jump -4 to NOP -4, the program terminates. After the last instruction, ACK plus 6, program terminates by attempting to run the instruction below the last instruction in the file. With this change, after the program terminates, the accumulator contains the value 8. Fix the program so that it terminates normally by changing exactly one jump to NOP or one NOP to jump. What is the value of the accumulator after the program terminates? Okay, so let us think about this now. So here's what I want to do. So I want to do two things. One, I want to give me a reset. Actually, no, that's fine. Def terminate self returns a bool. So I want to know if this function terminates. And so what I want to do is so it's almost going to look like and I'll call this does terminate execute equal set. So while self.index not executed, if self.index equals len of self.instructions, so that means it's pointing after the last one, return true, and otherwise, and then if we break out of that while loop, we want to return false. Okay, does terminate. And I don't need these So let's just make sure that that's the case. Okay, and now let's find terminator, and let's take some instructions, which is a list of instruction. Okay, and it's going to return an int. So for I instruction in, well, I'm going to try this the brute force way and we'll see if it works, and if it doesn't then we'll have to be more clever. You write instructions, but there's only 600 of them, so it will work. If instruction dot, and let me do another tuple unpacking now, op.arg and enumerate instructions. So if op equals nop, we want to sub in a different instruction, which is it was op to jump and jump to op, I think. Is that right? Nop to jump and jump to nop. Sub instruction jump arg. And actually, elif op equals jump, sub equals instruction nop arg, and then otherwise I just want to continue, because if it's an accumulator, then I don't want to change it, I don't think. Okay, and so now what I want to say is I want to say let me see what they called it, by changing, so I'll call it changed. Changed equals instruction, actually let me do it this way, it'll be a little bit easier. Let's say cloned subbed equals instructions this, so this is a copy of it that we can mess with. Subbed I equals this, subbed I that, and now let's say booter equals booter based on the subbed instructions, and if booter dot does terminate, then I want to return booter dot accumulator, and it's a new booter each time. And raise runtime error, no never terminated. Okay, so if you change second to last instructions after that should be 8. So we want to assert that find terminator of instructions equals 8. So let's try this. So that seems to have worked, and let me take out those prints because they're don't like them. Okay, so now let's try print find terminator of instructions. 552. All right, let us try it. That is the right answer. 1 gold star closer to saving your vacation. Okay, good. So I feel like I should clean up this code because I think it's probably going to get reused again. But what did I do? So I made a type for the instruction, and if I were building a production system, I might think about using an enum for the op to make sure that it's just one of like a fixed number of types. I don't think I want to do that. It seems like too much work for not much benefit. An op and arg, and I'm sure in the future they'll probably have me add to this, I would say. And then as always, I have the static method for parsing that does the natural thing. And then this thing, I thought about calling it a computer, but you call it a booter, and it just takes a list of instructions. Has an accumulator and has an index that keeps track of where am I at my program. And then they gave me this logic for executing one instruction, right? This is one really nice thing about using name tuples is that they are tuples, and so you can tuple unpack them like this, which is super handy. And then you're like, why didn't you just use tuples? Well, there's some times where you'd want to do like .op and .arg. So this, you get the best of both worlds. And so people ask me, oh, do you like data classes? Do you like data classes? Well, I don't think you can do this with data classes. So I don't like data classes. Stop asking if I like data classes. I don't like data classes. I like name tuples because you can do this. This is awesome. And so if it tells us to accumulate, then we just add the arg to the accumulator, go to the next index. If it's jump, then we change the index by that arg, and if it's a no op, we don't do anything, and we go. So run until repeat. That was pretty simple. We just keep a set of ints. I'm actually surprised that it didn't complain about my type int, but whatever. It says here are the instructions we've seen, because they want us to find when you get to an instruction you've already seen what is the value. So that's just a while loop. Just keep going until you get to something that you've seen before. Add to the set to say, hey, this index I'm at, I have executed it, and then call that execute one. And then a very similar one for this thing that says, do I terminate? And again, I keep track of things that have executed. And as they point out, if given the way things work and given that there's no like variables to store things in, if I get back to a place where I've already been, it'll just keep going forever. So if this while loop fails, meaning that I see an instruction I've executed before, I know I'm in an infinite loop, so I return false. And if I happen to be after the end of the instructions, then I know that it terminated and I return true. And so then what they said is they said for part two, so for part one it's straightforward, whatever. For part two they said I want to either change a nop to a jump or a jump to a nop. And so I'll just iterate over instructions, again tuple unpacking, very clever. And because you don't want to modify a list while you're iterating over it, that bad things always happen when you do that, I use the slice trick that makes a shallow copy. And now because these are tuples and they're immutable, shallow copy is fine. If I were using data classes, say, in this case it would also be fine, but in general if I were using like mutable classes, you probably wouldn't want to make a shallow copy because you could mess things up. And so now now that I made a copy, I can modify that copy. So if it's a nop, just replace this ith element with the corresponding jump, and if it's jump, replace the corresponding nop. And if it's the accumulator thing, there was nothing to do, so we just skip that and say that's not something we want to investigate. I create a booter with that changed program, and I've been told that there is only one booter, or there's only one change that's going to make it terminate. You know, if I were being like really ducks in a row, I would check that that only happened for one, but they told me it was only going to happen for one. So booter just once I find a booter, which means once I find a substituted set of instructions that does terminate, I return the accumulator because that's what they wanted, and that's that. So pretty straightforward, pretty clean. I predict that tomorrow they're going to have us take this and build on it. So I'll probably just copy and paste it tomorrow and build on it, because yeah, that'll be nice. So that was good. That was easy. No problem. Thanks for watching. I will see you.